Hi, everyone. Welcome to the Physionic podcast. My name is Nicholas Verhoeven. I'm a PhD student in molecular medicine, and today's topic is going to be a relatively involved one. I'm going to be discussing specifically I'm going to be discussing how much of an impact obesity or being overweight has on your risk of having severe complications from COVID-19 or the virus Sars Co2. I'm also going to discuss some potential mechanisms as to why that might be the case, as to why overweight and obese individuals tend to have a higher risk. And you may definitely want to stick around for exactly how much of a higher risk, because it is pretty surprising. And then I will also briefly touch on why some fit people, some really, really fit, like you're talking like marathoners, triathletes, bodybuilders that are suffering some really ridiculous amounts. Like you may have seen people post these kind of isolated stories of he was really fit or she was incredibly athletic and they struggled with COVID-19 and they just escaped and they barely survived, or they died, or whatever the article might be talking about. So I'm going to be covering all of that in this podcast episode. So without further ado, let me jump right into the first kind of area of this topic, which is obesity. So there was a French study that tried to compare retrospectively, so kind of looking back, and wanted to know if you were to categorize how critical certain situations were for COVID-19, so the symptoms that people were experiencing, could you stratify that based off of BMI, so body mass index, which is an indication of if a person is normal weight, overweight, obese, severely obese, or even morbidly obese. And while I completely understand if you're relatively educated on the topic, you might be rolling your eyes because I'm saying BMI. I completely understand. I'm probably going to say it many more times in the future, but I understand that BMI isn't a perfect measure by any means. But again, for the general population, I think BMI is usually a good indication, aside from the kind of interspersed exceptions to the BMI standard of measurement. But so let's put that aside for a second. Let's just assume that for the most part, BMI is going to be a relatively decent standard for the general population. So what they ended up finding was that they looked at the number of people, or the percentage of people that ended up on ventilators. So the implication there, of course, is that they're going to be in a highly critical scenario, that they're kind of on the precipice of potentially dying from their COVID-19 symptoms. So they found that 42% of those individuals, so 42% of normal weight individuals ended up on a ventilator. So that means that that's a BMI of 25 or under that. Now, of course, that does not take into consideration the low end of that, because being underweight, of course, can also be detrimental, but most likely that's not going to be a huge percentage of that normal weight condition. So 42% were normal weight, and this is, of course, not in the same population, so it's not going to add up to 100%, just to be clear. 64% of those who are overweight ended up with the ventilator in this situation, so that's a BMI of 25 to 30, and you can easily calculate your BMI. Just to be clear, if you just go to a website, just type in BMI calculator, you can figure it out in less than 30 seconds. And because all you need to know is your weight and your height, but in meters for height, and also for weight, you're going to want kilograms. And then 60% for obese. So obese was a BMI of 30 to 35, and then 82% for severely obese. So we're talking about a BMI over 35. And those individuals unless maybe you're taking steroids, there's not going to be much debate on if you are obese at that level. Any BMI above 35, even the most muscular of men will not have a BMI of 35. So that is for sure going to be, or relatively for sure going to be, pretty indicative. So you can see there that for normal weight individuals at 42%, there's certainly a lower amount of those individuals that are ending up on a ventilator as opposed to the severely obese individuals that were ending up on a ventilator. Like, you're almost guaranteed, if you're severely obese and you ended up in the intensive care, that you were going to end up on a ventilator. So that was, now of course, there's certainly, I might as well mention this real quick, there's certainly going to be issues with a study like this just because they're not controlling for, just all kinds of different variables. But I think one of the chief variables that would not be controlled for is that you don't have a standard practice for when a doctor is going to say, okay, now we need to put this person on a ventilator. So if you look at a hospital, and this is a French study, I may have mentioned this, but if I didn't, it's French. So you may look at a hospital in Paris and try and compare that to a hospital in Bordeaux, and suddenly things are going to change because the doctors in Bordeaux may be a lot more conservative about putting a person on a ventilator, as opposed to doctors in Paris may be more liberal, may be more accepting of using a ventilator for individuals at the same level of needing of care. So if they have certain blood parameters, or if they have certain medical parameters, one hospital may still keep them off the ventilator while another hospital will put them on a ventilator. So that can certainly be a huge confounding variable for a study like this. So it's something to mention just because, as usual, I try to bring up, a few other talking points and a few things for people to consider as a whole. So, but anyway, regardless, this gives us a little bit of information on kind of how things are stratifying. So it gives us some information, some data on the idea that if you are obese, then you're going to have a much harder time dealing with this virus. That's essentially what I'm saying. Now, then I looked at a study. I shouldn't say a study, it was a review, and a non-statistical review. So it was just kind of going through, these researchers had gone through a series of different studies, and then what they did was just kind of talk about the results of many, many studies, and wanted to come to, a few different hypotheses as to why this might be the case, and they had a little bit more data. So on the data front, they mentioned that there was a 7 times greater probability of ending up in intensive care if you were obese compared to normal weight. So that's huge. That's a massive jump. So being obese certainly has some dramatic negative effects on the ability to overcome this virus, Sars CoV-2. So that's kind of the data front on all this. And there's definitely more data out there, but I think overall, I think even the CDC has mentioned that being overweight or being obese is a risk factor that plays into the diagnosis and kind of how to deal with Sars CoV-2. So just something to keep in mind. If you haven't been infected or haven't been exposed to this virus, it may be a good idea. It's always a good idea, right, to try and lose weight just for general health. But of course, in this situation, it's a little more, it's a lot more poignant that you want to keep yourself as healthy as possible. And weight loss, I've talked about this so many times, weight loss is such a huge, huge driver of overall better health if you are overweight. That's a big stipulation there as well. So, and that's who we're talking about in this situation. So, what were some of these hypotheses? And I'm actually going to go through several that they talk about in this review. And then I'm actually going to talk about one that I think may be playing a role as well, based off of the mechanism of SARS CoV-2. I've mentioned this before, but SARS CoV-2 binds to the ACE2 receptor, and I'll get into that mechanism at the end, or near to the end of this podcast. But That's more related to my interpretation of what may be going wrong with these individuals, and just in general, not necessarily just people who are obese. So according to this review, they offer a few different hypotheses as to why this ended up happening, why obese individuals are suffering so much. And so one of them is due to metabolic dysfunction in the immune system that's driven by typically diabetes and obesity kind of go together, at least type 2 diabetes. So those usually go together. And you can imagine that with diabetes, you're going to have a lot of pathophysiology, meaning that your physiology isn't going to be functioning as it's supposed to. The cells of different organ systems aren't going to be functioning as well as they should be. A prime example of that is like the pancreas, right? Is constantly pumping out insulin, trying to control your blood sugar levels. So that's an example kind of generally of the pathophysiology, but what would that exactly mean in terms of metabolic dysfunction for the immune system? Now, I will admit I haven't actually read a whole lot of studies into this topic yet, just because, I'm busy with so many other things at the moment, including my qualifying exam that's coming up actually next week. So I have to worry about that, and I have to be very muscle focused to get through that. But once that goes by, hopefully I will have much more time on my hands to actually attack some of these more obscure topics that I haven't had the chance to discuss. But I will say that a few months ago, I did read a paper specifically on the metabolism change in the immune system. So if I were to discuss that and kind of put that in context here, is there are immune cells called macrophages, which are part of our innate immune system. So they're right now, you and me, if you're listening to this, or if you're watching this, then you have macrophages that are just kind of floating around in your bloodstream and through your tissues, and they are essentially just like security guards. You can think of them that way. And they're pretty big cells, but they're security guards, and they kind of just slip in and out of different areas of your body, just like with spotlights almost, just looking for things to gobble up and destroy. Now, when they are in a a resting state, they tend to look kind of blob-like. I mean, they kind of look a bit circular, they're just casually moving through things. And they tend to, from what I remember from the papers, that they tend to focus on a fat metabolism. So they tend to use more fat to produce the energy that they need to survive, to live. And then when they encounter something that needs their attention, they need to destroy it, or they need to somehow take care of it. That's when they shift to an activated state. And there is debate, I'm not going to go into it, but there is debate on if there should be a gradation in terms of the activation state. It shouldn't just be resting and activate. It's not like a light switch. It's more of a gradation, but I digress. The point being that there is a shift in metabolism to more glucose-centric, meaning more carbohydrate-centric. And with that shift, you have this highly active cell that suddenly becomes more aggressive and starts to deal with whatever pathogens are around it, or whatever issues are around it that it perceives as something that it needs to deal with. So you can imagine that if a person has diabetes, or if they are obese, then they aren't going to be in a position where their cells are constantly bombarded with the wrong signals, essentially, throughout their normal life. And then you throw a virus on top of that seems to have this serious impact when it comes to immune function. The whole immune system becomes really active. You have all these immune cells that are going to this particular location. If for some reason you may have a shift, you may have difficulty shifting to that activated state, or maybe they stay in that activated state, or maybe they get into that activated state and then they fail to produce enough energy for all the different functions that need to occur. That can cause some serious issues when it comes to your metabolism, and of course the metabolism within that immune system. So that's a speculation based off of a few studies that I've read on the topic, specifically looking at metabolic dysfunction in the immune system and then trying to couple that to diabetes and obesity. So then another hypothesis that this review came from, and this is from Circulation, which is a really big journal. They're highly reputable journal, usually looking at heart disease, but in this situation they were trying to make sense of obesity, and of course obesity is highly linked to heart disease. So Sars CoV-2 may also affect the pancreas directly. Now, if there are ACE2 receptors on the pancreas, and we know that, and I have a podcast on this already, where Sars CoV-2 has been shown to affect all kinds of different organ systems. I mean, it can affect, obviously, the lungs, the intestines, especially the large intestine, the colon. It affects the liver, it affects the nose, it affects the brain. It can affect all kinds of different areas. So it would not at all be far-fetched to think that maybe SARS-CoV-2 can affect the pancreas. And like I just explained, if the pancreas is already struggling to release insulin, to produce enough insulin to shuttle blood glucose, blood sugar, into the cells, then you have this, it's like an insult to injury, or more like injury to insult in this situation, because then the virus will then enter those pancreatic cells and start destroying those pancreatic cells, specifically beta cells in this situation. So that tissue, that organ system that's already struggling to function properly, is then bombarded with a virus. And then you can imagine a bunch of immune cells have to flood to that area as well and start destroying a bunch of pancreatic cells. So that's something to consider as well. And then once your pancreas starts going, you're in pretty deep doo-doo, to put it lightly. Okay, so then the other thought that they had was, well, obesity also increases thrombosis, so the blood clot that can be formed. And obesity, of course, I just mentioned with heart disease, increased risk of heart disease, but also has increases in blood pressure, right? You've got more mass on you, you typically have increases in blood pressure. And with that comes blood clots, and blood clots can certainly add to blood pressure, because you start having this closing of the venature, or the artery side of the body as well. So either side, you're having less and less room for blood to be able to move through. And sometimes that can end up releasing like chunks of whatever material ends up creating that clogging, can actually break off and start to move down finer and finer areas of venature, or vasculature. And then that can get stuck somewhere, and that piece will get stuck somewhere in the vasculature, and then it will stop or impede blood flow to the other side. So that leads to, well, the death of all cells, essentially, that are on the other side of that blockage. You can think of it like a dam, right? If you completely close a dam, then there's no more water getting to it, so all the fish that are on the other side of the dam, well, they're going to die because they have no water. And all the people that require water from that dam on the other side downstream are also going to die because they can't get water. So it's the same situation here. So obesity is, of course, a prothrombotic, meaning pro-blood clot forming issue. And then COVID-19, one of the symptoms is prothrombosis, so an increase in those blood clots being formed. So it's just another situation here where you're kind of getting a double whammy. Just like the pancreas, you're getting a double whammy there. With this, you're getting a double whammy on the ability to deal with clots, or the formation of clots in general. Another thought process that they mention is potentially reduced lung function from weaker muscles. I think that this is probably a little bit weaker of an argument, simply because when you're breathing, you're not using your musculature that much. It's really based on your diaphragm. But if you do any sort of forced exhalation or forced inhalation, then you will be using that musculature. So maybe on the tail end, if a person is really struggling to breathe, like they have pneumonia, as a secondary injury from COVID-19, then that can be an issue because you're actively trying to breathe in and breathe out. So you have to actually concentrate, and you may not be thinking about it right now, but you just kind of go out throughout your day and you're breathing normally. So that's not going to be that much driven by your musculature, in the sense that, like with exercise, after a while, if you're really pushing yourself hard, you stop exercising and you realize you're heaving, right? Trying to try and pull together enough oxygen, enough air, and try to release as much carbon dioxide as you can. So in that situation, the musculature is important because it's going to allow for that forced exhalation, so the breathing out of CO2, and the forced inhalation of oxygen. So I think that's probably more kind of really close to a person dying, to be honest. If their lungs are completely filled or starting to fill up to the point where they feel like they actually have to actively think about, oh, I need to breathe in now. Oh, I need to breathe out now. And that would be incredibly terrifying because you're essentially drowning. But because of those weaker muscles, because they haven't been used through exercise, through specifically aerobic exercise, cardiovascular exercise, then they're going to be weaker, and therefore they're not going to be able to pull in as much or push out as much as they might need. Also, I guess another point, I should have mentioned this earlier, obesity already just has general higher levels of inflammation. So just having higher levels of inflammation itself, and then you throw a virus on top of that, that's going to, of course, explode the situation. Also, there is apparently a study, I did not read this study, but based on this review, they mentioned that there is a study, and potentially other studies, where they've looked at obesity and it actually impairs the adaptive immune response to specifically influenza. So let me break that down real quick. I mentioned the innate immune response when I was talking about macrophages. So macrophages, neutrophils, things of that nature, those kinds of cells, those are always essentially present. They're just always around. And they will trigger, activate, and then attack whatever pathogen is around. Now, if they sense that they can't deal with a particular issue, it's not really like they're thinking about it, but just through the whole biology of the situation, if they end up needing more help, then they take a pathogen, destroy it, crumple it up, break it apart, and then they present pieces of that pathogen, a pathogen being something that's dangerous or attacking our body. And then with those pieces, it will then activate, and I'm skipping steps, but it will activate the adaptive immune response. And the adaptive will then kind of use that as a clue, as a marker, and then start to try and create antibodies and try and deal with this virus or this pathogen, but in this case, this virus, with much more specificity, but also producing millions and millions more cells to essentially grow the army of your immune system to fight off this virus. So you can imagine that if obesity impairs the adaptive immune system, and this is specific to influenza, so it's not far-fetched to think that it would also impair it against Sars Co2. So in that situation, it may be apples and oranges, but it could also be apple and red apple and green apple. So it could be very close. So in that situation, then obesity will have a direct impact on reducing the ability to respond to Sars CoV-2. So those are some of the thoughts that they had in the circulation review. Now, if you'll indulge me, allow me to get some of my physiology off. There's another thought that I have, wherein we use the mechanism by which the virus functions, and we can garner some clues from that. And I do believe that this could be, and I would imagine that this has an effect, maybe even the primary reason why people who are obese or have high blood pressure will suffer specifically from this virus. So there is a system that regulates your blood pressure. There are numerous systems, but this is one of the major players called the Renin Angiotensin system. This Renin Angiotensin system, I'm going to go through how your body normally functions, and then I'm going to backtrack and explain how the virus could be affecting this system. Normally, you have the release of a molecule known as angiotensinogen. I'm emphasizing that because it's kind of important when I go into two of the other molecules which sound very similar. So angiotensinogen is released by the liver. So once that gets released, you have an enzyme by the name of Renin or Renin, which is released by the kidneys. And it's kind of cool how these different systems are working together to regulate your blood pressure. So Renin will then cut this angiotensinogen to angiotensin. So angiotensin 1. Okay, so then angiotensin 1 is then bound to another enzyme known as angiotensin converting enzyme. Now, if you've heard me talk about the virus before, please forget what I said just for a minute. I will return back to that. That is, we're not talking about angiotensin converting enzyme 2. We're talking about the first one, angiotensin converting enzyme. So then angiotensin converting enzyme, well, just like the name implies, it converts angiotensin 1 to angiotensin 2. So they don't get too creative with it, which is nice. And then angiotensin 2 will then eventually lead to this increase in blood pressure. And through this, that's how we regulate kind of the bottom end of our blood pressure. If blood pressure starts to dip, starts to decrease, which is not something you want. You don't want your blood pressure to be 0, because if it's 0, you're dead. But you also don't want it to be too high. Well, on the bottom end, this is that system that's going to control that. So it's going to release angiotensin 2, and therefore then you have increases in blood pressure through a mechanism of vasoconstriction. My apologies, vasoconstriction. So think of like a hose. So your vasculature, your veins, specifically your arteries, to be frank, your arteries have muscle around them that allows them to constrict. And when they constrict, because you have a certain amount of volume in your blood system, in your vasculature, in those arteries, then that blood volume, once it's being constricted across the body, that means that your blood pressure increases because it's a closed system. It's the same thing that if you were to do it to a hose. I always use this as an example. If you were to close the end of a hose and then turn on the water, and then let's say you have a set amount of water and you then stop the water coming in. So you've got this closed system. The hose is pretty packed, filled with water, and then you were to squeeze in on the hose. If you were to measure the pressure within that hose, that pressure would increase, and maybe the cap that you left at on the end of the hose may pop off because of that pressure. But that's just speculation. But regardless, you would see an increase in pressure, in water pressure. Well, for us, we have a ton of hoses going through our system, and that leads to an increase in our blood pressure as opposed to our water pressure. Same thing. So that's how it normally should work. Now let me go back to the virus, SARS-CoV-2. So SARS-CoV-2 binds the ACE2 receptor. And now we know that it not only binds the ACE2 receptor on just the lungs, but it also affects the liver, and it affects all these different other areas, and even the heart. Now, the reason why I'm mentioning this now is ACE2, remember it's angiotensin converting enzyme. The problem is that now there is a new way of looking at the Renin angiotensin system. So because this ACE2 exists, what it does is it degrades angiotensin 1 and angiotensin 2 to other forms of angiotensin. I'm not going to give you the names, it doesn't matter. And typically what ACE2 would do, when you get this degradation of angiotensin 1 and angiotensin 2, then you end up with greater vasodilation. So the opposite of vasoconstriction. So if ACE1 were to have its way, you would see increases in vasoconstriction, so greater blood pressure. However, if you have ACE2 there, then you'll have some of that that's kind of buffered by going through ACE2 and then be degraded so that you don't end up using it for ACE1. And therefore, you have greater vasodilation. So the vasodilation being the opening of those vessels and therefore a lowering of blood pressure. Now, why am I mentioning this? Well, because Sars CoV-2 binds the ACE2 receptor, it is possible that it's not out of the realm of possibility that if it binds enough of it, that it could actually have a physiological effect. That, and this is, keep in mind, this is all speculation. I'm just going off of my knowledge of physiology and pathophysiology, and I'm kind of proposing my own hypothesis, just like the circulation review. So if the SARS-CoV-2 binds the ACE2 receptor and kind of takes it out of the function, out of the physiology, the normal physiology, so you have less ACE2 around because it's being bound by so much SARS-CoV-2, then that means that you have less of that being, less of the angiotensin 1 and 2 that's being degraded to end up increasing vasodilation. Therefore, you can have more of it available for it to go through the ACE1 path, or the canonical pathway, and therefore you would see increases in vasoconstriction. Now that would further increase blood pressure. So you can imagine now, try and put that together with people who are obese and people who have high blood pressure, have hypertension. Now imagine you have another driver of hypertension. Suddenly you're getting like a triple whammy there of, I keep saying whammy. I don't know why. It's not like a thing for me. But regardless, you have this triple hit of increases in blood pressure. And of course, that's going to have a profound impact on your heart. And that's going to have a profound impact on your cardiovascular system. So that could be another contributor, maybe even a major contributor to how SARS-CoV-2 is having a direct impact on obese individuals specifically, or really just people that have hypertension, if that's hereditary as well. And then the final thing that I wanted to briefly discuss is why fit people might be dying, because I just talked about how obese people are in far more danger as a result of being severely overweight. Fit people dying. Now, here's the thing. I keep seeing this, and this is probably just, I'm in my own bubble, so I see this because I'm around people that are, they're fit. Typically, not that everybody I know is fit, but like, a lot of people that I know are fit. So they're posting things about fit people dying. And it's like, oh, this is scary, right? And it is, no doubt. But there needs to be context applied to that. And I think the best way to apply context to that is that we see these isolated articles of like, oh, he was, like I mentioned at the beginning of this podcast, oh, he was super fit and then he ended up dying from COVID-19, or she was super athletic and she barely escaped, like she was on a ventilator for 21 days and then finally recovered from COVID-19. And I think one of the issues that I have with that is that certainly that's true. I'm not by any means saying that it's not true, but the problem is that it's an isolated article. So if you're looking at statistics of people in general, like perfect example is like what I've just been talking about. You look at the obesity statistics, and we're talking about tens and hundreds of thousands of people. And then people are like jumping on a single article, or maybe even 3 articles or 4 articles. The fact that there's an article written on it should give you some like pause to think, oh, well, I mean, maybe they're pointing this out because it's rare and they don't have any other examples. But that aside, it's still just an article. It's about one person. So that could be for any number of reasons. Now, that said, because this person was fit, that probably helped them out with this whole like recovery process, even though it may have been devastating for them. It probably still helped them out overall, because of all the reasons that we just talked about for obese individuals, why it's so detrimental for obese individuals, while fit individuals would be, in many manners of speaking, kind of the opposite of that, having benefits in, blood pressure regulation, body fatness, all that, musculature, all that stuff, their lungs function better, like all that stuff, right? It's all going to be better for a person who's generally fit. So focusing in on these particular stories and saying, oh, well, this also affects fit people. Yeah, it does. No doubt. I mean, again, I'm not invalidating the fact that these people went through this horrific infection and that they barely survived, or, maybe they didn't survive. But it still isn't, it shouldn't be put on par with the thousands and thousands of, individual people that really have risk factors. So to point out just a few isolated cases of fit people isn't much of an argument. It's not like a fit person isn't in a better position. They are. That's just true really across the board for any disease, right? If you are fit, then if you've taken care of your body, then in whatever capacity you're able, then your body's just going to be better, in a better position. A great example of this kind of phenomenon that I'm talking about is illustrated in my video where I say that science is wrong, and where you can't look at a single data point and say that science is wrong. You have to still consider that data point. It is part of the data. However, the clustering of data, the majority of the data, is actually applicable to saying that fit people are in a better position. And that is absolutely true. So I just wanted to address that as well, because I really have seen quite a few people post like, oh, no, we're just as susceptible. No, that's not at all true. You are not just as susceptible, but I will say, I mean, for certain fit individuals, being fit no matter what is going to help, but you can still have a genetic background that may, and we're still figuring this out, science is still figuring this out, doctors are still figuring this out, to figure out why some people just have, especially with certain race backgrounds, it must be maybe some sort of genetic profile. I don't know. I don't know the reason why. It's certainly all speculation at this point. But certain individuals just really suffer badly from this infection. And then a lot of people just like some people don't even know they have it, they just brush it off. And some people have really mild symptoms, and then you have some people that are kind of in the middle. So I do feel like there's a lot of heredity, a lot of genetic traits that play a factor. But taking care of yourself, regardless of your genetic background, taking care of yourself absolutely unequivocally will help against this virus, and really just any infection, but certainly against this virus. So keep that in mind. Okay, that's what I've got for you. Hopefully you found this informative, and I hope to have the pleasure of speaking with you in the next one. Have a good one, guys. See ya.